Let's continue our discussion with talking about lunar phases. So this is the phases of the moon, and this all stems from the sunlight that is hitting the moon and lighting up only half of its surface. So looking at the Earth and the moon, we can see that only half of the objects are lit up, okay? And this continues no matter where the moon is. But we do have moon phases. And the question is, why? Well, the reason we have moon phases is all because of our perspective. So what we see from Earth, okay? So the sunlight is always lighting up only half of the surface of the moon, okay, as you can see here. Now, um, we only have half of the moon lit, but our perspective is going to change based on that. So if I insert all of these lines, okay, we see that we have a dark side of the moon and then a light side of the moon, okay, or the far side and the dark side or near side, okay. Now, our first phase, which is what we typically start off with, is called new moon. Okay, and that's when it's seemingly closest to the sun, the moon. And if we are looking in this direction, maybe I should use a different color here. If we're looking at the moon, trying to see it, we're looking this way, we are just going to see all of this dark side of the moon. That's all that will be in our perspective. Okay, so I'm going to say all about our perspective. Okay, so we'll just see all of this here, all of this dark side. So we will get our new moon. Then as the moon orbits around Earth, we first get our waxing crescent, okay? And again, we're not going to get a just half of the moon. We're going to get, the dark half. We're going to get a little sliver of light. Okay, so this is called our waxing crescent. Okay, then as we move along, we will look straight on to this moon. Okay, and we will get half light and half dark. Okay, so this is where we have our first quarter. Okay, so we can see a quarter of the moon now, or actually it's we can see half of the moon, right? But this is the first quarter in its cycle. Okay, this is the first quarter in cycle. Okay, again moves along, and we'll see most of the moon, okay, during this time, and that's called the waxing gibbous. Okay, we will see from this perspective more light than dark. Okay, then as we look at E here, we will only see light here. So we will now have a full moon. Okay, so again, we went from new moon to first quarter all the way to full moon. Okay, and then we'll have to go back. So now we will start losing that light that we had. So from this perspective, again, we have a lot of light, but now we have a sliver of darkness here. Okay, again, looking here, we will now have third quarter. We're 3/4 of the way through our our cycle. Okay, and then we get all the way to our waning crescent. I should have continued our little arrows here. that motion. Then we have our waning crescent when we have a small sliver, but now, as you can tell here, it is on the other side of the moon. Okay, so as we start out, we have the right side of the moon where we have a little sliver, and then at the end of its cycle, right before new moon again, we have it on the left side. Okay, and this is called waning crescent. Then continues on to again new moon. Okay, so these are the phases of the moon. And I think once we can look at something in class or maybe a simulation, it will click a bit better. Okay. Okay. So the moon rotates on its axis and revolves around Earth or orbits around Earth. Okay. And those two things actually take the exact same amount of time. Okay. So it rotates on its axis like it shows here, where it's got that rotation. Okay. And it orbits around Earth. So the time it takes for it to go to rotate one time is the same amount of time it takes to orbit one time. Okay, so the rotation and the orbit are equal. So the rotation time and the orbital time is the same. So that is why we will always see the same face from our perspective on Earth. So we always see the same exact face, okay? This same face will always be facing Earth, okay? So that's what these little arrows show. Same face, okay? All right. One more thing about the dynamic between the moon and the Earth is there is a gravitational pull between the two, okay? So there is a significant amount of pull um, of the moon on Earth. So this is some sort of um, uh, gravitational force that the moon is putting onto Earth. So the moon is pulling on Earth, okay? So moon pulling on Earth. And with that, it pulls the one thing that it can pull on is going to be whatever is on our surface, and a lot of that is water. So let's look at an image of this. Okay, so the moon will pull. Okay, so this is the moon, say, and the moon is pulling, and so water on Earth will build up on that wherever the moon is closest to. So if it's closest to the equator, okay, then we'll have the water kind of moving towards the center edges or center portions along the equator, right? So let's say around here is equator, somewhere around there. And so that's where we'll have more tides happening, okay? Or high tide, I should say. And this also depends on where the sun is. So we have what's called spring tide and neap tide. So spring tide is when we have the moon and the sun on opposite sides of Earth. Excuse me. And they both have a force due to gravity that is pulling on Earth's surface. So this is why we get the spring tide. Okay. And then we also have neap tide, which is when they will be opposite. So the sun isn't going to be putting as much of a pull on Earth as the moon, but we'll still get a little bit from the moon. Okay. So this is when we have neap tide, or that would be like low tide along the equator. Okay. So again, that's equator. Okay. All right. So that is the reason for tides. It is all because of the moon. Okay. All right. I'm going to pause here and continue in our next video.